right, so let's do some more contextual problems, but this time we'll look at those that involve number theory and distances. So we're looking at number theory and distances for contextual problems. Sorry about the audio there. Here we go. The sum of the squares of 3 consecutive integers is 194. What must those integers be? Well, let's say x is the first of my integers. And if they're consecutive, then the one that comes after it would be x plus 1, and the one after that would be x plus 2. So it says the sum of the squares of those 3 consecutive integers, that would be x squared. That's the square of the first one. X plus 1 squared is the square of the second one. And x plus 2 squared would be the square of the third. And that has to equal 194. So we've got a quadratic to solve. So we've got x squared plus x plus 1 squared is x squared plus 2x plus 1. Let me expand it out. X plus 2 squared is x squared plus 4x plus 4. When we expand that out, and 194 goes on the end. Collect all of our like terms. We have 3x squared, looks like a 6x, and then a 5. And we have to subtract 194 when we put all that together. So that's going to be 3x squared plus 6x minus 189. Right on. So divide everything by 3, and we've got x squared plus 2x minus 63, I believe. Oh, look at that. It's a nice quadratic with factors. 2 factors of negative 63 that add up to positive 2, plus 9, minus 7, and away we go. So that tells me that x is going to equal negative 9 or positive 7. We'll use our zero product property and work that out. So we've got 2 solutions to check here. If x equals negative 9, our integers would be negative 9, negative 8, and negative 7. And if x is equal to positive 7, we would know that 6 is afraid of 7 because 7, 8, 9. All right, let's move along. At midnight, a runner leaves Montreal heading west at 10 kilometers per hour. So the distance problems are all kinds of convoluted things here. 2 hours later, another runner leaves Montreal heading north at 5 kilometers an hour. What time to the nearest hour will they be 50 kilometers apart? Let's see. 50 kilometers is the distance we want to have between these guys. The first one that was heading west was going at 10 kilometers an hour. And the one that's heading north is traveling at 5 kilometers an hour. So if I'm traveling at 10 kilometers an hour, after t hours, we'll say after midnight, I'm going to travel 10t kilometers. Now this one would travel 5t kilometers, except that he loses 2 because he starts late. So we're going to say 5 times t minus 2. And then we're going to write a Pythagorean theorem equation. So Pythagorean theorem here is going to tell us that 50 squared has to equal 10t squared plus, we've got 5 outside of t minus 2 squared. And now we have an equation with t in it, so we can solve to figure out what that time is, or the number of hours after midnight. That'll tell us at what time. So 50 squared, I think, is 2500. And 10t squared is going to be 100t squared. Plus 5 squared is 25. And t minus 2 squared is t squared minus 4t plus 4. Okay, before I go any further with this, I'm going to divide all this stuff by 25 and make it look a lot nicer. So this is going to give us 100 over here equals 4t squared. And then plus, we're going to have t squared minus 4t plus 4. So that just simplifies our equation a lot. Let's kick it all together here. So we're going to have 5t squared minus 4t, and then 4 minus 100 looks like negative 96. Okay, I think that actually might factor. It's going to be complicated factoring, though, perhaps. Let's use quadratic formula just for fun. So we'll say t equals negative b plus or minus the square root of b squared will be 16 minus 4 times a times c, all divided by 2a. And that gives us 4 plus or minus the square root of a bunch of stuff here. Now, let's see. 5 times 4 is 20. So 20 times 96, oh boy. I'm getting 1920. So I've got, for this, we've got 16 minus, which now becomes plus because it's subtracted negative, 1920 all over 10. Okay, So we'll continue along then. And that tells me I've got 4 plus or minus the square root of 1936. What happened that year? Great Depression. World War II. Lots of stuff almost about to happen. All divided by 10. Okay, so if we're going to figure this out then, we've got to find a square root for 1936. So 4 plus or minus a square root of 1936. And that's 44. So that's not so bad. All over 10. So if we work this out with the plus, we're going to have 4 plus 44 all over 10, which is 48 over 10, or 4.8. And if we work it out with the subtraction, we're going to get 4 minus 44, which is negative 440, over 10, and we get a negative 4. Now, I don't think the runners went back in time, so we'll call that one extraneous. And we'll keep this one over here that says 4.8 hours. So 4.8 hours, they said to the nearest hour, so we're going to say at about 5 a.m. It's 4.8 hours roughly after midnight to the nearest hour. All right, good question. So when solving number theory problems, it's just about writing an equation to model the relationship with a variable representing one of the numbers that we want. That'll help us get the others, so it's not a big deal there. And for solving distance problems, we use that d equals vt formula to represent distances for moving objects. And then Pythagorean theorem is nice, especially if we want to get a quadratic out of a triangle. Pythagorean theorem has lots of squares in it, so it usually works out really nice. And as always, remember, we're not getting the vertex. These are not max-min problems here. We're going after roots of the equations. Good luck. We'll do a couple of more examples next time.